Today we're going to look at the sand mining case study. This is for section 4B in the OCR A-Level course, looking at how economic development can change coastal landscapes. And we're going to look at this area called the Mangawhai-Pakiri Coast in New Zealand, and we'll just have a look at where that is in the world. So now we're going to look at the location of our case study. It's in New Zealand and it's in the North Island, and it's near Auckland, which is a major city, and it's this 20-kilometre stretch of coastline right in front of us from Mangawhai all the way down to Pakiri, and the sand is taken from offshore because the sand is very, very high quality there. It's suitable for use in the construction industry, and this has been happening here for over 70 years. So here's a actual footage of a drone going over the coastline. So this area here is Mangawhai Spit on the left, right in front of us, and the actual town of Mangawhai to the right. And these are areas that are affected by the economic development of the sand mining. And here is one of the main stretches between Mangawhai and Pakiri. It shows the beaches, quite steep sides, and this basically just gives an overview of what actually looks like the place that we're going to be studying. Now we've seen the area of the case study, we now need to look at why are we interested in this area. So we're interested in the area because it's an area of sand mining. Firstly, we need to know why sand's so important in economic development. Well, it's a material that can be used in a whole range of economic uses, so it's a really, really valuable resource. It can be used in the construction industry, it can be used in concrete manufacturing, it can also be used in glass manufacturing, but another key area that we're going to look at is how it's used in beach replenishment recharge, and we talked about rainbowing last lesson. So this area of coastline, we need to know why this area in particular rather than another area. Well, the first thing is that the sand that you would get from the near shore off of Mangawhai to Pakiri is really high quality. It's excellent for construction. This is particularly important because right nearby we have Auckland, which is a really large urban area, has a third of the entire population of New Zealand and 35% of the GDP. And this whole area, this Auckland area, is growing economy in terms of business and finance and the high-tech industry, but also tourism. And so in tourism, that means beaches, coastal amenities, and so there is a lot of demand for the high-quality sand that they're extracting in the near shore here. So when we're extracting the sand, we have boats like this sand mining ship, which kind of sucks up the sand and then it's filtered out and then it's sent back onto land. And we need to look at how much sand has been extracted in this area and what effect it's had on the sediment budget. So like I said, it's near shore sand extraction, so it's coming from just off the shore. And the extraction rates have changed over the 70 years that they've been doing it. In the 90s, the rates were as high as 165 metres cubed a year, but they actually stopped at Mangawhai Beach in 2005, but still Pakiri is an area that still to this day they are actually extracting sand from. The rates have gone down and they're about 75,000, but still lots of sand being extracted there, and most of this sand is going to top up and replenish the beaches down in Auckland, so for that burgeoning tourism industry. Obviously, if we extract a lot of sand, it has an impact on the sediment budget, but it also has effect on coastal landscapes. So one of the problems was this sand that was deposited in the near shore happened during the Holocene, so nearly 9,000 years ago. And because that's not going to happen again, this is non-renewable. Well, you could say that systems are normally open and so we should be able to top it up. However, this area of the coastline doesn't have many rivers, and there isn't enough waves bringing extra sand from offshore. So most of the sand would have been offshore and moved in, but not enough of it's happening. So this is why it's non-renewable. No major rivers to input more, and no waves, again, bringing more from further offshore to replenish these nearshore supplies. Therefore, we can argue, in essentially this area, it's a closed system, closed sediment system. This is problematic because at the moment the extraction rates are 5 times the inputs that are going into it. This is really problematic because that overall supply of sand is therefore shrinking. So we've got huge loss of that very limited amount of sand. And when we shrink that supply of sand, therefore, this is going to impact the stores and the movements between them, and it's going to affect, therefore, the landscape in which these exist. So let's have a look at the impacts on the landform. Here's an example of a spit breach, and in 1978, because there's less sand being put onto the kind of beaches and less sand being able to protect the spit, therefore when a big storm happens, those high energy waves are able to breach the storm. So breaches caused by high energy waves being able to attack the spit and the beaches, which aren't able to protect them because they're not getting supplied with sand, are quite significant. So that 28-metre breach actually altered the tidal currents in this area. That means in Mangawhai Harbour, there was more sediment suddenly being actually pushed into the harbour because the tidal currents had changed. So the fact that we'd lost sediment in one area actually changed the patterns elsewhere. That means we get more sediment in the harbour, and that means it's actually shallower. And when it's shallower, unfortunately, that leads it to being an area now that's more at chance of flooding during storm and kind of high precipitation points, and therefore the Mangawhai community is now more at risk. So they're having to do way more dredging actually in the harbour now to try and mitigate that. So the impacts of dredging somewhere else have led to more consequences on this harbour and the areas surrounding it. We've also seen impacts on the beaches. So because there's less sediment in the system now, less sediment is making it onto the beaches. That means the beaches are flatter. They're not as curved and high as they would normally be, and that means they're less effective at absorbing those high energy waves, and so less of a buffer between that and the rest of the land. We also see similar impacts happening on the dunes in this area. So because there's less of a buffer, these what we call foredune ridges, so the first dunes next to the sea, are actually undercut by high energy waves, which means that they actually lead to kind of slumping and mass movement, and that causes these really steep seaward facing scarps, so these steep angled ridges. And that is largely because there's no sand there to create a bigger beach and protect them. It also means that the vegetation on there isn't stabilised, and so you get loss of vegetation, which in itself makes this area more prone to wind erosion. So just by taking away some sand from this input, we're seeing lots of the bits of the landforms and the landscape being altered in this area. This could be something that continues in the future. It's something that, because we've put the sea system out of equilibrium, and we talk about equilibrium in our course, therefore, as rising sea levels along with the sand mining continue to occur, we're going to get long-term retreat. So we're going to get erosion rates here that are far more significant than elsewhere. So it could get up to 35 metres of retreat on this bit of coastline, which is considerably more than any of the beaches in this region. And you've got to kind of factor in the fact that sand mining will have a big impact here, and therefore cause bigger effects here than perhaps in other bits of the coastline, especially on those beaches where maybe this sand is actually ending up and protecting those areas and communities.